Okay, welcome to our second lesson of the unit on function notation. So this is going to be basically some things we've seen before, but it's a new type of notation that we use with functions, and it's one of the reasons. The nice thing about functions is that we can actually use this notation, and so let's look at what it looks like. Um, so here's a question to think about. So given f of x or equals 3x minus 2, and f bracket 3 equals 7, f bracket 1 equals 1, then you have to determine what f of f bracket 5 is. So you can pause it and think about this. Where might the 7 come from? Where might the 1 come from? How is it related to 3? How is it related to 1? When you thought about it for a bit, you might come up with the fact that when you sub in 3 into the equation, you get 7. And in fact, when you sub in 3, you get 3 times 3 minus 2, which is 7. If you sub in 1, you get 3 times 1 minus 2, which is 1. So if you want to figure out 5, so if that pattern kind of holds true, you could do 3 times 5 minus 2, which is 13. And this is actually what function notation is. It's talking about, so the x value there beside is actually the input value, and the output is the number that comes out. And so this is going to be a way to describe inputs and outputs for different functions. So today we're learning how to represent linear and quadratic functions with function notation and how to substitute into and evaluate functions. So I'll show you an example like of a real world problem. Not so real anymore, I don't think. But say we have a membership fee of $10 and we can make downloads for 50 cents. Using traditional variables, we might say things like this. Let x represent the downloads, let y represent the cost, and so we have like a y equals mx plus b, 50 cents is our slope, and then $10 is our fixed cost. Using function notation, it looks very similar. It's just that the y is replaced by this f bracket x. So f of x, we call it, would be the cost instead of y. And what this highlights is that the cost is really based on the downloads. If you had very complicated functions, you might have multiple inputs. But in functions in high school, we generally talk about one input giving one output. And we noticed this, like if you wanted f of 5, you could do 0.5 times 5 plus 10. That would give you $12.50. So 5 downloads cost $12.50. But you can also say things like f of 5 equals 12.5. And notice that we're really just emphasizing that the cost is dependent on the input downloads, the x value. So in general, and I've alluded to this already, we read this f of x. These are not brackets in the same sense that it's multiply, so f and x are not two different things being multiplied. F doesn't really exist without the bracket x, so we keep it. We'll use different letters like G and H and V and things like that for different types of functions, especially if you have multiple functions on the same grid or in the same question, which we'll see in a second. But like the common mistake is people think of this as multiplication and think that, well, if they want to isolate x or something like that, but that doesn't work. It's like the input value is x and the output's the f of x is the total answer. So you can see here, like if the input value is -2, the f of x is -7, and we're really just showing this to show you that it's the same as y equals mx plus b. F of x is the same as y. It's still a straight line, but you can see that when you sub in, say, 0, you get -3 out. And so this would be written as f of 0. This would be written as f of 1 would equal -1. Some examples. So if we wanted to find out f of 5 minus g of 5, we really just sub in 5 to this one and to this one. And we can do it separately. So sub in 5 everywhere you see x. So you get 5 squared minus 3 times 5. Make sure you put brackets. There's no negative sign here, but you should still have brackets whenever you substitute in. So you get 25 minus 15, which is 10. So this part of it, f of 5, is 10. So that's the output. And then the g of 5 part is negative 9. You take your time with that one. But then the question is asking you to subtract those outputs. So if you had inputs of 5, you'd subtract the outputs. So 10 minus negative 9, there the bracket really matters. 10 plus 9, which is 19. Simplifying the second one, it's just telling us to double all the outputs, so double the function. So what we're going to do is just double the function, and the function's x squared minus 3x. And so we double everything, and then the simplified part, you can argue whether that's simplified or not, is just to double the x squared and double the negative 3. So you get negative 6, and that's the distributive law. Then the next one is saying instead of subbing in x, we're actually going to sub in x minus 2. And so instead of having 1 minus 2x, we have 1 minus 2 bracket x minus 2. And again, the brackets matter when we substitute in because we have the distributive law that means that everything in the bracket gets multiplied by negative 2. And that's the simplified part. And so we get negative 2x plus 4. And then combining like terms, we get 1 plus 4 is 5, 5 minus 2x. And the last one's saying like, just add the two functions together. So that's what we're going to do is add the two functions together, x squared minus 3x and plus 1 minus 2x. Combining like terms, you get x squared minus 5x plus 1. Okay, so there's a lot going on in that slide, but it's just to kind of show you what different inputs and outputs mean and how we use function notation. We might say 2f of x, and that means 2x squared minus 6x, the equation. Another example, you want to find x given g of x is 10. And so we sub in 10 for g of x. So g of x is 1 minus 2x. So if we subbed in 10, it's just now it's saying that the output is 10. We've got to find the input. So we solve the equation, subtract 1 from both sides, divide both sides by negative 2. We get negative 4.5 or negative 4.5 or negative 9 over 2. Those are all fine answers. So the input would be negative 4.5 to give you an output of 10. Okay. Why is function notation necessary? It's really a more efficient way to describing a point when you have a function. So f of 3 is 5 means when the x value is 3, the y value is 5 for the function f of x. It's kind of a lot to write, but like if you had like an f, a g, and an h, it might not. So just say 3 comma 5 might not be that descriptive. Like it doesn't tell you what function is 3 and is the output. And so f of 3 is 5 is saying like when that x value is 3 for the function f, then the output's 5. Allows you to do something with the output without having to find what the output is. So like back here when we actually had we said take the outputs and add them. That does it for everything. And so like if we had f of 5 plus g of 5, we could just plug in 5 here. And so we actually don't know what the outputs are, but we can do it in general. So this is saying double all the outputs. So if we put an input in to this equation, it's basically going to double them all. And in programming, that will allow you to do more complicated things, and that'll allow multiple functions.